My name is Gaiki. My name is Calabar.
Yo, my peeps, what's up? How are things? Hello?
I'm there.
You're about good. All the studies.
Sir, all day Monday, me away paying for open up the edical staff and I go and do my thing. And you wait till this man, me there working a meeting, you work me.
Me say,
But I love you still, me.
me say, I have no behavior now. Whenever private message from me, CD. I saw the
Sir,
message
I
and I say,
recommend you in the group.
I know. Me see the message and I say, yes, I'm going to do it. And so by the time to move from where I was to go to the computer to do it, I got distracted. And when I saw the message again today, I was around the computer. And my Charlene says, please, sir, just remind me. He said, Jesus. The session reach it. All right, go to session reach it. The session will cost me.
Oh, sir, so a Charlene.
A Charlene alone in
No.
A Charlene alone in like.
Leave that.
I got stop.
Leave it.
I
Listen
got
to me.
stop coming to the class. Yeah, I'm Germany
in the class. Germany in the class and Germany.
Sir, I'll overlook the something and a cuss about oh nobody not help Ryan.
No, it's true.
And
I'm gonna say right now.
overlook me a begging for
No, it's true.
Time. How long will I beg him?
It's true.
But a Charlene come in and say,
take time to say that.
Everything
Germany in the class. Germany in the class. Take time. Germany pump 250 pounds a day time, you know. Right? Me no pump them someday. So careful, Germany in the class. No man, you know, on a Christmas. You plead the fifth.
Sir, I don't look back on it yet, no, but when is it open until?
I'm opening for a longer period, man. For a longer period, so it's good.
But guys, when
Charmaine beg him nicely, so I open it longer for you.
No, but after our plan for attack it and try to figure it out over the weekend.
Yeah, man. You can't.
Sir, just flap a show. Trim the desk inside and eat him lobster lunch and him
lobster.
No,
shrimp.
No,
and
man,
him shrimp, you know.
Miss Swims? No, sir. Yes or no? Ryan, trust me, danger lurks. And he see the big man in the class and him now so he's pleading the fifth because him no and Charlene she laughing and say, honey, don't say anything here. Me not getting a no cockroach and fall fight. You understand?
If only sir knows him I call up the wrong name, Charlie. But me leave people business alone.
Bless the Lord, oh my soul, and all that is within me. You know? So come and get myself in a trouble, you know. The next thing the other one quiet and ready for a boil up soup for me. Never mind. Shall we move on? It is a wonderful day for us to have class tonight. And I am really hoping and trusting that, matter of fact, Arthur, have you up? You see, everybody said them have me up, me have you up. But we will talk outside of class. All right? We will talk outside of class. Nobody even respond to me. You message me after class. All right. You know, guys, it's really a good day. And, you know, truth is, wait a minute, sir, you all right?
Sorry to interrupt you, sir.
Go ahead.
I have a problem. Sir, I don't have any Wi-Fi. So I put on service and my phone is not working.
Oh, no, you have a big problem.
Yes, sir.
All right,
but
never
the
mind.
Wi-Fi to come back, you know. But I'm just, you know, the Wi-Fi is
will come back.
Here, but
okay.
The phone, I don't have a phone, sir.
All right, never mind. Just stick with us. You'll get a recording, and you know, if you have any difficulty, you can always shoot me a question. So not to worry about it.
Okay.
Never mind. Cool. All right. So I'm feeling a little excited for the class. One of the things that I will say is a few of you in here are honest with yourselves, and I love the honesty. So I have been getting, you know, one or two little side talk, you know, sir, this is my issue, or sir, that is my issue, or whatever else the situation is. And I really and truly respect it. I have been, giving counsel both in and outside of class. But what I want you to do, students, is to really be honest with yourself. And what I mean by being honest with yourself, I want you to assess yourselves in terms of digesting the data, not computer students, digesting the information, and to see how well you can reproduce the information on your own. If you're having a difficulty, you must sit down and wait until it broke out in one big sore. Let us deal with it when it, at completing unit 1, moving on to unit 2, let us deal with the issues as they arise. So I really respect that, and I look at those students differently to say, sir, this is the truth. And it's not 1 or 2 or 3 students, but I've had conversations with a few outside. You don't need to know who, they know themselves. And I really like the honesty. And if you keep up that general trend, I honestly believe that you'll be successful. Just be honest with yourself. Put in the work. Don't recognize that there is an issue and not put in the work. I mean, that would be very stupid. Recognize that there's an issue. Talk to me. I can give you little tips and I can say, okay, this is what you need to do, etc., etc. And do you go to class Monday through Friday?
Yes, sir.
Okay, so therein lies my problem. So what I was thinking of, I spoke with ICT today to do something for me. I told them that I wanted it from yesterday. So the gentleman is supposed to be doing some stuff and sending me something by later on, hopefully tonight. But what I'm thinking of is is to see if maybe I will do one of the classes for teaching, and then I will do the other class for just working questions, just to give those an opportunity who are lagging, just to catch up. But just work with me and you will catch up. All right. With that said, we did some piecewise function. I'm pleased with, yes, man, you need to get the question right. I'm able to learn now, come need to make the mistake with the question. But guess what? I gather with the piecewise function that some of you have grasped it, others of you are struggling with it. Others have grasped it, others are struggling. And I don't enjoy, it's really not very sexy when students don't understand what is happening. And me a teacher and I go along, and me alone feel bright. I want all of you to be at the same pace. So here goes. I am going to give you guys a challenge for me. I know you were looking for other piecewise question in the we call it now, on the past papers. Anyone else was able to find one of those piecewise question past paper? I just want to catch one to present it to the class and to go through it again as a refresher for those who don't catch it so well. And what I'll do in class today is a little summary for you, so it is that you can have that. So please, I'm going to ask that you look through your set of papers. You will find them quicker than I would. What am I looking for? Jesus, this is that. Okay. And semester 1.
Sir? Wait, sir, yes. So we can print, right?
Yeah, man, I finished unit 1 now, I'm finished with unit 1 now. All that I'm going to be doing is just a little touch up. I'm going to start unit 2 today. Maybe I start unit 2 the last an hour from now, maybe the last half an hour of the class. I'll start unit 2. Matter of fact, I started unit 2 already last week and I never did know it. Somebody asked a question and I went through the definition of continuity And we have been looking at one or two of the ways that we can find out whether a function is continuous, but I'll go through that. So yeah, so let us just use a portion of maybe about an hour, 45 minutes, thereabout, to, what am I looking for? To go through that for me. So do me a favor, go to the past papers for me, please. Go to the past papers for me and look at the to see if you see any more piecewise questions on it. Whether or not to find the piecewise questions, we still can do some limits questions. So all of those things can come. For one of the questions, you can get A, B, C. A, you get a limits question or two questions in it for limits. They may give you a little one question on piecewise, and they may give you a little one question on continuity, and that is 20 marks. So you got on one question already out of the exam, I have two more questions to go.
Sir, December 09, question 3. A pretty simple one.
December 09, do me a favor now. Oh Lord, December 09.
Sir, while I try to find that, what is the L hospital rule and will we be learning that?
Yeah, man. The hospital rule, yeah, man. I will do all of that with you.
Or is that it? Okay.
Yeah, man.
Sir, did you get a chance to look at the question that I sent you today?
I don't think that was a good time for you to ask that question. I don't think the timing was right because Miss Unique Gordon will start from me and here, Miss Straight Lisa will start and say, You
can't move in here?
Oh, you know, sir, that me assess, sir.
No, we cannot know you by now.
Sir, am I name here at the end of that?
No, sweetheart. Why would I call Miss Unique Gordon's name? No, sir.
Okay,
have me weak. All right, let's go. All right. So I did answer the question that yes, you can go and print, but I'm feeling.
Sir, before you go any further, just check your chat. I sent you my I got started out today with my email. I sent it to you. You can check.
Okay, yeah. See it there. Yes. All right, cool. I am trying to, yes, please go ahead.
The last thing that you wrote on this, sir, I don't think you did it correctly. Method 2, that one.
Yeah, what I did. Method 2 right here. Eliminating B. Let me just double check. Eliminating B. So it's going to be.
So the same thing I have in method 1, sir.
Oh, what I did was to copy and paste, so maybe I didn't correct something. So yeah, you're correct. You are correct because I copied and paste. Yeah. So subtracting 1 from. All right. So hold on, let me just check. Because this looks the same as this. Oh no, it looks correct. Subtracting 1 from 2. Subtracting 1 from 2, that means it's going to be 2 minus 1. So if I subtract 1 from 2, it's going to be 2 minus 1. So it means 3a minus A is 4. Supposed to be 4a. Supposed to be 4a. I have B. Supposed to be 4a, and then 2 minus 2 minus is minus 4 times 1 4. I only copied and pasted and didn't. So that's supposed to be a, and that is going to be negative 1, and that is going to be negative 4. And then put a to be negative 1. A to be negative 1 into equation 2 3 times negative 1 plus b, and then that is going to be negative 3 plus b is equal to -2. And then -2 plus 3 is going to be +1. So B is +1. So let me just check the answer here. Yep. All right, look at the correction for method 2 for me, please. So B is +1. What should I have? B +1 and A -1, you know? Yeah, it's because I copied and pasted. I didn't change it. So have me pardon. But that's very good observation. Tells me that you guys are learning. Bueno. Look at the correction for this one, please. Anybody find any other question than the simple one that was identified earlier? Hold on, 1 minute, please. Continue looking for me. Give me 2 seconds, please.
December 2013, question 1. I think this is part C. There's another simple one too.
All right, again, thanks for that correction. So I will have to send you this document again to effect the changes that I just made. Okay, the question. Can somebody read the question for me, please? Not seeing my past papers, so. Anybody, somebody? Am I being heard? Are you hearing me?
December 2013. Question 1, C.
All right, read what the question says for me, please. What's the function? Give me the function. F of x. What's the first equation?
8,
Mm-hmm.
comma, x is less than 5. Sorry.
Mm-hmm. X is less than 5, yeah?
Yeah, and the second one, 2x minus 2.
Mm-hmm.
X is greater than or equal to 5.
Mm-hmm.
Determine if f is continuous at x equal 5.
Oh, this
Give
one does have
reason.
2.
Yeah, that's what I was saying is
Okay. Okay. All
simple.
right. All right. So all right. So Lord, I pray. All right. All right, give me half a second and just fix this thing properly. No. Mm-hmm. All right, just look to see if what it is that I have there on screen is what is on the paper.
Yes, sir.
What's the instruction now?
Determine if f is continuous at x equal 5. Give reason.
Is it give a reason or give reasons?
It doesn't give reason.
All right. Let me give you an opportunity, about 3 minutes, to do this question for me, and I will do the question myself. An opportunity to do the question. I'll do the question myself, and then I have something floating around in my headspace that I'm going to write. And matter of fact, let me write what it is that is floating in my headspace. Start that question for me, please, guys. Let me write what is floating in my headspace so that I don't lose it.
Good evening, sir.
Hi, how are you doing today?
Tired, sir. Tired.
Oh, never mind. You will be fine. You will be fine. Mhm.
So before work this out, sir,
Yes, please. Just do a quick
I find the
1, 200.
answer already, sir.
Nice job. All right, give me just a few, but I'll wait on the others.
Good evening, sir. How are you doing?
Well, I'm about to take an easy one for you.
Tired, stressed, something on my mind.
All right, so Anika just said the same thing a while ago. She came on like a minute before you. What I was going to say to Anika is what I'm going to say to you now, and I'll say to the pair of you.
Sir, Sasha, not Anika.
Oh, sorry, it was Sasha who said it?
Yes,
Right.
sir.
Sash, you know,
Yes, sir.
I'm gonna tell you something, Sash. Somebody said something in a class today, and somebody say, I wonder if Sasha reached a class yet. Cause you know say Sasha will start. We don't know who says so Sasha. Well, I tell you, say them students are serious something, you know. Anyway, Sash, don't look into it too deeply here. Your teachers will see you in trouble. But yeah, the truth though is, when we're tired, we know that we're still living. Because when we have complete rest, we are very dead or sleeping.
Yes, sir.
So sorry, you're afraid to call your own name?
Oh Lord, I love it. I love it. I love it. I love it. I love it.
Boy, sir, you're sounding bipolar, you know. We have to check you out, you know, sir. We're gonna check it out.
No, I see. With what is happening in the world now with COVID and everything, live. Live and let live. Don't let me COVID get the stress out here. Live and enjoy the life that Father God give you. So I'm just grateful for to be standing in my grave here. 5x squared, 5x squared. All right, everybody finish with that now? 5x squared minus 4. All right, so that sounds like a no because I don't hear 12x.
Yes, sir.
Yeah, think so.
All right, I come in.
Yes, sir.
X is greater than 3. X is greater than 3. All right, so let me just check to see if that is fine. 5x squared minus 4. 12x plus 3, x is greater than 3. All right, so let us determine if the function is continuous at x equals 3. All right, easy 1, 2, 3. This we don't know. What's enough of the question I'm going to ask the general to do.
Sir, question. How much more that question were the first one?
First one, because Lexington, a big school only there, maybe they give about a 4 or 5 marks.
What, 2 marks?
Or even that too. No, about 4 marks.
Okay, all right, sir.
All right, so all right. Okay, so let's go. Your teacher is not lazy, he's also working very smart. Let me just copy one solution and go down there. Unfortunately, when you go into the exam, you're not going to be able to have that flexibility, but in the interest of time. All right, so we're checking for x equals 5. So the limit of a constant
is the constant itself.
Very good, excellent. So the answer for this is
8.
very good, very good. So the limit of a constant is the constant itself. Always remember that. Always remember that. So that's why, you know, when the question was being sought, the person says, sir, I find one easy one, you know, because everybody knows, say, 8 to the first piece. So in order for it to be continuous, the next piece better be 8. If it is not 8, things don't look right. And based on what I can do quickly in my head, 2, 5, 6, 10. 10 minus 2 are 8. So you know, it's continuous. So in my headspace, I can work towards the question already, knowing what my answer is going to be, right? So I'm saying this to say to you, not afraid of the question. Don't afraid of it. The question is just 2x minus 2. Don't be afraid of the question. Tackle it and you will be fine. Minus 2. And that's going to be 8. So if you look at it now, okay. So let me just not jump the gun as if all of you at the same pace. Let me just go again as if I'm teaching you this for the first time. So it says determine if f is continuous at x equals 5. Give reasons for that not construct properly. Give a reason. Whatever it does, that f of x is equal to that, comma. Determine if f is continuous at x is equal to 5. Give a reason for your answer. All right, easy 1, 2, 3. All right, look. Oh no, I hate when this happens. Hold on. Okay, must I read only 5? All right, so let's go. So what I'm doing here now is at x equals 5. I know that I must look to the left of x equals 5, and I must look to the right of x equals 5. I'm trying to find if this function is continuous at x equals 5. I must look to the left and right of 5. From my piecewise function, which are the functions in the piecewise function? Agree with me that the piecewise function f of x contains 2 functions. One is 8 when x is less than 5. One is 2x minus 2 when x is greater than or equals to 5. All right? So, which of the functions deals with when x is to the left of 5? Tell me.
8.
Very good. It will be 8. Sir, how do you know? Less than is to the left. Remember, sir, say L for L, less than to the left. So I'm going to have that being for the first part of the question, which is why I have x going to 5, 5 to superscript minus is suggesting 5 to the left. All right? And remember, recall the limit of a constant is the constant, ITSEL, is a constant itself. The limit of a constant is the constant itself, now change. Just remember that. The limit of a Rockstone. Come on, don't play with me. Strange, undo. Right. So the limit of a constant is the constant itself. So when you basically questions like that, don't even get jittery and say, but sir, I don't see anything to substitute. Hello. The limit of a constant is a constant itself. All right? Limit of a constant is a constant itself. So let's move on to the next one. No. If the one that talks to the left, that means the next one must be to the right. If I have 2 functions of the piecewise function, if the one here to the left, the other one must be to the right. Let's check. x is greater than or equal to 5. Yeah, man, sir. It's to the right. So we have 2x minus 2. 2x minus 2, remember we're not using the intuitive approach, so we're going to assume that x is 5. Anywhere in the function I see x, I put 5. 2 times 5, see it right there, so minus 2. Then I'm going to get 2 times 5 is 10. 10 minus 2 is 8. Now, I can tell him, say, give a reason. See my reason here. Reason, R-E-A-S-O-N. Hold on there. All right. I felt a sneeze coming on for about 10 minutes ago now. All right. So let's go. Give a reason. So the reason is that since the limit as x tends to 5 to the left of 8 is equals to the limit as x tends to the 5 of that minus 2. Then f of x is continuous at x equals 5. Now, Lexon asks a very good question. Sir, about how much a question like this will cost. And realistically, you'll get a mark for the reason. So if you don't have this, you don't get the mark. Hold on. So I get a mark to say that it's continuous because it says determine if x is continuous. So I get a mark to tell them that it is continuous because that's what the question asks me. Give a reason for my answer. This would be a reason. So that's 2 marks. Lexon is about 4 marks. I did say 5 is 4 marks. So I get a mark for evaluating the limit to the left. I get a mark evaluating the limit to the right. I get a mark to say whether or not it's continuous, and I get a mark to say for the reason. So this question will be a 4 marker. All right, a 4 marker question. All right, now very good. Now I just copied this one that I'm going to call I do know.
It was worth 5 marks, sir.
It was worth 5 marks?
Yes, sir.
You don't know where I'm going to get the other mark from, but anyhow, it's a 5 marker. That's fine. That's fine. They're generous. Maybe they will give you and I see what they could possibly do. Maybe they could give you 2 marks for this here, 1 mark for that. That's 3, 4, 5. Or maybe they give you 1 mark for this for sure. They give you a mark for the correct substitution, and then the correct answer. It could be 2 marks here, and then they give you 1 mark for the reason and 1 mark for that. So it could be 5 marks. All right, fair enough. I give you I do know. Now hear me out. While you work on this question, there are some students who are not 100 on this. I want you to be very honest with yourself. I was looking for a book that I have here that I know I have some Piecewise questions, and I can't find the book because I'm not seeing as many of them in the past papers. So I want to give you, matter of fact, let me go look for the book. Go and work on this one, please. Work on that. I'll soon come. Are we finished with this one, guys?
Yes, sir.
Very nice. You know, let me confess something to you. It's when I answer questions, I can almost predict the ones who are going to be answering me. And I need to hear from those who are not so talkative in class to respond. I need to know that you guys are understanding. It's very important. So please, I'm going to ask you to just respond to me. Please.
Got it, sir. Got it.
Nice, nice, nice. Bless up.
Sir, where did you get this? Which year paper did this
You
question
know,
come from?
to be honest with you, this one here came from a business calculus paper. It came from a business calculus. You know, business calculus class paper. You know, for me, I could look at the yeah, it came from a business calculus class paper. And what I did, I found I didn't find any. I don't know where to put hand on that book. But I found something else that I made us do something differently today. And the reason I'm doing this is based on the questions that have come to me in one-on-one conversations. I am going to be giving you some questions. Now, when we finish this question, what I'm going to be doing, I'm going to be typing some questions on the screen. I'm going to ask you guys to work on those questions. I will call on different individuals to let me know, for you to tell me your answers. Then the class will tell you whether or not you're right or wrong. Then we'll do the question together. This is like me giving you classwork, but it is supervised classwork, right? And the question here is going to be mixed up, so to speak. What if I mix up something? Infinity and then something there that we have already covered. So technically, it's nothing new that we have been doing. It's just old stuff that we're trying to get through. All right, let's go. So we need to do this at x equals 3. At x equals 3. Copy. Paste it there. At x equals 3. Okay, so we need to look to the left of x equals 3. What is to the left of x equals 3, please? Answer quickly. What is to the left of x equals 3?
5x squared.
5x squared minus 4.
Very good. 5x squared minus 4. Is there anyone in the class that is not seeing how the students were able to say 5x squared minus 4? If so, please let me know. Say something. Don't just sit there and not speak to teacher. All right, so 5x minus 4. So what we're doing, anywhere in the function we see x, we're going to assume that it's going to be equals to 3. Anywhere in the function we see x, we're going to assume that it's equals to 3. So 3 squares is 9. 9 times 5 is 45, I think. And 45 minus 4 is how much?
41, sir.
Very good. So we get 41. Let me just take out this thing because that does not apply right here. All right. So it is going to be equal to 41. Very good. Excellent. And of course, because it is 2, if we know that one is to the left, the other one has to be to the right. But let us check. X is greater than. Yeah, man. It is greater than, so it is now that we're going to, oh, cockroach. Remember, I don't do the sketch. Maybe I can put out that topic and then just maybe do 1 or 2 sketches with you. The 12x minus 3 is to the right. How you know, sir? X is greater than 3. So to the right of this, to the right of it, it's going to be x is greater than 3, and it's going to be 12x plus 3. It's going to be 12x plus 3. Anywhere in the function I see x, I'm going to assume that it is 3. So it's going to be 12 times 3 is 36. 36 minus 36 plus 3 is 39. Also?
Yes, sir.
Yes, sir.
So what's my statement? What's my statement? Is it continuous or discontinuous?
It's continuous.
Continuous.
Very good. Excellent. Excellent, guys. Very good, very good, very, very good. I'm actually very proud of you. 5x squared. I'm just writing my statement. 5x squared minus 4 is very good to see that you're getting a 12x plus 3. And this is going to be when x equals 3 to the right. It's not equals to, sorry. Right, so this is a good example to show that not all the questions you will get them to be continuous. Some of the questions you'll get to be discontinuous. So f of x is discontinuous. D-I-S-C. So f of x is discontinuous at x equals 3. Is there anybody in the class that does not agree with this? Would want us to have a look at it? We can have a look at it and we can have a conversation about it. Is there anybody in the class that is not understanding what is happening here? All right, okay. So let us do so let us look at a summary. For evaluating piecewise functions.
A question is asked in the chat,
Oh,
sir.
thank you, dearest. I mean, remember, I can't. What is meant by discontinuous? Okay, excellent question. Now, who wants to take what is meant by discontinuous? Who wants to take that? All right, speak up here. Go ahead. Go ahead. When I answer them not equal. Okay, Ramesh. All right, fair enough. Thanks much. All right, who asked that question? Ryan, but Ryan, unmute for me, Papa, please. Ryan, talk to teacher. Come quickly, Ryan, quickly. Unmute for me, please. Is it that you can't talk or you're not hearing me? Ryan. All right. So,
sir, question. Suppose you write the f of x, the f of x is not continuous at x equals 3. That all right?
Same difference, Papa. So it's a negation. It's a negation. And for you, I never studied computing, but I did math all the way up. And there's a section of math that is so connected with computers. So you talk about the AND gate, the NAND gate, and the NOR gate. These are conjunctions. So if you say discontinuous or not continuous, discontinuous suggests a negation. Or if you say not continuous, it suggests the same negation. All right? So if you want, you can say discontinuous or not continuous.
Sir.
Yes, Papa.
Connected now.
Oh, this Ryan? All right, answer teacher. I'm not putting you on the spot, right? And remember, you know, guys, when I call upon you to talk to me, I don't want anybody to think say shame, ready to shame you. This is a family, and if you know in your own families, there are times when you may have disagreement. Husband, wife have disagreement. Pitney and daddy and Pitney and daughter, and we have disagreements. In this class, we have disagreements. All right. But we're going to move past our disagreements in order to be able to pass the course. And I'm going to tell you, there are times I'm going to be very upset with you. There are times I love Kelvita, but there are times I'm going to rough up Kelvita. But guess what? Kelvita can't say, sir, no love her as much as they normally love. No, it is because I want Kelvita to get to where I want Kelvita to get. So when I ask you to unmute, just unmute and just talk to me and talk to me honestly. Ryan, I'm going to ask you a question. You asked the question in the group, what it means by discontinuous. Okay, fine. I'm not going to answer you just yet. Do you understand what it means by continuous?
No, sir. I missed this class. I'm trying to catch up now.
Okay, fair enough. So you don't understand what it means by continuous?
No, sir.
All right, okay. So why I asked you to unmute, because I wanted to quiz you if you understand continuous, because if you understand continuous, it means discontinuous is just the opposite. You hear the question that Lexon asked? And that's why I amended it to say discontinuous or not continuous, because one is a negation. It's either yes or no. So one is a negation. So let me go again. And thanks for your question. Thanks for your question. It's an honest question and I have no problem answering it. So let us go back to the question before. The question says, given that f of x is equal to this piecewise, determine if f is continuous at x equals 5. You need to determine if x is continuous at x equals 5. All right? Now, look at what is happening. Oh, come on, don't do this to me. Look at what is happening. So if you look at it now, we are going to be working the question. So to check for continuity, we have to look to the left of the something and to the right of the something. We can't just say, yeah, put in the answer or assume that x is equals to 5 in both of them and we'll work it out. No, we have to investigate what is to the left of the function, what is to the right of the function. Very similar to what it is that we did for the intuitive approach. Remember, you know, as mathematicians, we are very inquisitive. We are an inquisitive set of people because we have to use the information. And just like computer people, only computer people inquisitive. Okay, this is happening. What happened before? The system, sir, I was using my computer and I get a blue screen. Okay, I know the next question is it the first time you've seen the blue screen? What did you do? Do you have, so there are some questions that you're going to be asking me, the user who is a novice in the computer. So it is that you can help to diagnose the real issue. Why it is that I'm seeing this blue screen on my system. You may say to me, don't shut down. Do me a favor, see if you can back up your information now because X, Y, Z, whatever else you may say to me. That's exactly what it is that I'm doing at Piecewise. I'm investigating what is to the left of the function, and similarly, I'm investigating what is to the right of the function. So in this here case, I'm looking at x equals 5. I'm looking to the left of 5, but guess what? I have to see which of the piecewise function deals with the left and which one deals with the right. Because sometimes them can put that one you're up here, so you know, and the one you're down here, so. So it's I don't want anybody to think that, oh, is the top one is always to the left. No, it so happened that based on what Sir give you, the top one is always to the left. But the man then can put the right one up at top and the other one down at the bottom. So you have to look at the function, which is what I teach you really how to do it. All right, but it so happened that the top ones are always the ones that we are working with to the left. But as I said before, this 8 could have been down here, so, and the 2x minus so could have been up top. And then if you don't really understand what you're doing, you may call this one to the left, and that will be wrong. But sir, you're not gonna get the same answer. But instead of getting 5 out of 5 for this question, it means that the function to the left will be incorrect, so you're going to lose the mark there. And it means that the function to the right will be incorrect, so you're going to be losing the mark there. So we may get 3 out of 5 for the question. And even though the question is fully right, you don't want to lose marks for doing something that is wrong. You don't want to do that. All right? For something that is right, I'm sorry. Right? Because you did something wrong in the steps above. So watch me. So because I know that I'm investigating what is happening at x equals 5, I'm looking to the left of 5. I am going to look into my piecewise, see which of these two functions deals to the left. And I say x is less than 5. Less than is to the left. Always remember, the L with the L. The two L's them go together. Them are brother and sister, them are twins. All right? The L and the L, left and less than. Left and less than. All right? So we know that this one is to the left, so we can write the limit as x tends to 5 to the left. Remember, this is not 5 minus, you know, it's 5 superscript. That superscript sign up there is telling us that it's to the left of 8. Now remember, we're just going to write by the 8. Sir, why? That me can't see. The limit of a constant is a constant itself. The limit of a constant is a constant itself. No matter what under your so, it could have been 1 million, trillion, zillion of 8. The answer is still 8 because the limit of a constant is a constant itself. All right. Now, similarly, I can't assume that because this one is to the left, that means the other one is going to be to the right. I have to double check it. So when I look at it now, but sir, I wanted the x right first and I wanted the x right after. It's not a problem. If you're reading from the x, you should be fine. Look, x is less than 5. X, the alligator mouth open up. So x is greater than or equals to 5. So once it's greater than, it's to the right. So you can write 5 plus. See there, 5 superscript plus of 2x plus 2. Anywhere in the function you see x, you assume is equal to 5. 2 times 5 is 10. 10 minus 2 is equal to 8. Now the mere fact, Ryan, that to the left of the function you get one answer, 8, to the right of the function, you get another answer or the same answer, 8, it means that the function is very well behaved. It is so well behaved, very well behaved, that it is a continuous function. There is no break in the function. There is absolutely no break at all in the function. So we say that the function is continuous since they are equal. On the other hand, when I look to the left of this function here, I'm going to get 41. When I look to the right of this function, I get 39. Them two not add up. Baby say, Daddy, can I go to the sweet 16 party? And Daddy say, no, because the boys them can look at you and I am sheltering you from them people there from early. And then mommy say, Lord Jesus, me should go. And yes, mommy can get. Mommy and Daddy saying two different things, confusing the picnic. So there is no, and then you say that the family is dysfunctional. They are disjointed. They can't make up their mind, right? So because they are going in two different directions, we say that the function is discontinuous, or we can say that it is not continuous because they are going in different directions, different answers. Is that clear, Ryan?
Clear as mud, sir.
Great, I'm happy for that. All right, half a second, please. All right, guys, forgive me. I don't know why it is that I'm having the sniffles, but anyway, let's go. Now, I want to create a summary document for you to evaluate piecewise function, and I want you to help me to do it. When I'm evaluating a piecewise function, and you can use that one as an example, then I'm evaluating a piecewise function. What's the first thing to do? Hello, somebody.
Repeat, sir.
When I'm evaluating a piecewise function, what is the first step that I must take?
Sir, what is to the left and what is to the right?
Okay. So investigate what is to the left and the right of the given limit. And the limit is tending to 3 right here. Do you accept that this is the limit here is tending to 3?
Yes, sir.
Good. So we're investigating what is to the left and the right of the given limit. What's the next step?
Sir, factorize?
What is the next step? How do you investigate?
The greater than or less than.
What did I do right here?
Substitution.
Very good. So having investigated, then I'm going to substitute. I mean, so, hello, and I'm supposed to write in the notes soon now. I'm supposed to do it, you know. All right, come. So we're going to substitute the limit into the functions. All right. Now, when we substitute the limit into the functions, what is the next step?
Calculate it.
Okay. What next?
Then you'll see if it's continuous or discontinuous.
When I say functions, what do I mean right here? So let me see if anybody following me. When I say functions,
That's like 2x minus 3, sir.
But when I say functions, why did I pluralize it?
Because you normally have two functions.
When we get two functions from Ramesh, tell me when we get two functions from.
The left than and the right and the greater
Very
than.
good. No, very good. The left and the right of it. Very good.
But sir, I feel like one step come before you evaluate the function, because even though you substitute, you have to pre-function in a way, because if you have A and B in it, you have to take a different approach than we normally do.
And I would agree, but guess what? I'm looking at a general solution to the function. And even if you're doing the general one, yes, this step can still evaluate what is happening, you know. And let me, for those of you who are not following what it is that he's asking, is a question like this: when it is that you have an unknown here, you're still looking to the left and right of the function. You're still substituting and evaluating the function, right? Then now we can put in another step, no, Ramesh. I would agree with you that if there is an unknown, the limit that you get to the left or right must be equated. You follow what I'm saying? As we did right here. Right here, we get the limit to the left right here, and then we equate it here, and then we do the same thing for the other function, and then we solve them simultaneously. So you are correct, but we don't finish yet. So we're going to investigate what is to the left and right of the given limit. We're going to substitute the limit into the functions. That is left function and the right function. All right. And then we're going to evaluate the functions. We're evaluating the functions. Now, so this is the next step now. So if the limits are equal, E, Q, U, A, L, comma, then we say that the function is CONTINUOU is continuous if the limits are different, ERENT, comma, then we say that the function is not CONTINUOUS or DISCONTIN or discontinuous. Look at that and tell me if you agree with what it is that we have there, what I have there. The limits are different. True, false? Talk to me.
No, sir.
All right. So, all right. So now, what's next? Ramesh, this is really what it is that we're doing for evaluating the sum of the piecewise function. And them 3 steps there is really it's enough. But Ramesh, you give a conditionality to something there. If if the piecewise, P-I-E-C-E, if the piecewise function contains an unknown or unknowns, what do we do, Ramesh? Do we still do step one?
Repeat, sir.
What if they sorry, let me just remove this here. So if the piecewise function contain unknowns, like we did in the other one, what do we do?
The simultaneous equation, sir.
No, man. Yeah, jump the gun, man. Talk to me now what we do. Guys, tell me. Say, so this one is for when it is that 1 and 2 is for when it is that it is straightforward. But if it contains an unknown, what do we do?
Alright, so you work the two function them, and then you find, then you do the simultaneous equation to find either A first or B, and then B.
All right, so what he's trying to say, sir, is you solve the known part to know what is the limit. Then equate the unknown to the limit.
So we're still going to investigate the limit to the left and right of the function. Talk truth.
Yes, sir.
All right. And then we're going to substitute the limit. Are we still going to be doing this part? Substitute the limit into the functions left and right?
Yes, sir.
Yes, sir.
All right. So that's what we ask you. Just walk me through the steps. Very good. Come on. Then what next? Talk to teacher. What next? Look back at what it is that we did. So when we substituted it to the, it says here, substitute the limit into the function, left function and right function, and evaluate the functions, right? So are we going to be evaluating the functions? Can we evaluate the functions right here and then? Say no. Say no. We're not working it tonight. Talk to me. Let me know if you agree with this.
See, senior.
All right, good. So, not because it's math. Math and English language and the English language, math is a language. Math is a language. And if you can understand, I normally do a summary at the end, but sometimes I don't have time to do it. So sometimes I'll come to class and ask you to verbalize for me. Because if you can verbalize what it is that you're supposed to be doing, the topic must be easy for you because you know what to do. All right. So, I will stop right here and then go through 6:30, go through some questions. All right. I'm going to drop some questions here and I'm going to answer. It takes a couple of minutes. I'm going to give me about 15 minutes to do these questions and then I'll come and do some stuff. Do now. Evaluate the limit as x tends to 2. This is the 2 of x squared minus 4. Over x squared minus 2x. X squared minus x squared minus 2x. Minus 4. All right. See, you have one question here so far. Start working on that for me, please. Which one can make it the most? And then you can give you copy, paste, 4x squared plus x plus 1 plus 3x squared plus 2x plus 1 3x squared plus 4 plus 3 4x plus x plus 1. All right, down to number 3. Mhm. Are you guys seeing my screen?
Yes, sir.
Oh, okay, because I see something that says screen sharing pause. All right, continue working. I'm actually trying to do the question myself, so at least I can share some stuff with you. All right, continue working.
Sir, I want to see the last question. Sir?
Sorry, I was talking to you guys and I didn't recognize I was muted. I was saying to you that I'm coming, I'm just copying something here because I refuse to retype the same thing.
Okay.
Yeah, so there you go. You're on your own again. All right, I'm ready. We have 5 minutes. What is offer the answer for the first one? No, somebody?
0, 0. First one?
Mm-hmm.
I got 2, sir.
Got 2. Everybody got 2? All right, that's what I did, and I got 2. Everybody agree with that?
Yes.
All right.
Yes, sir.
All right, good. So since you agree with that, I won't necessarily go through the question. So I'm just dealing with those who answer. If you're not agreeing, let me know you not agree. I'm only answering those who are actually speaking to me in class tonight. So you have a responsibility. What is for the answer for the second one though?
I get 4 or 3, sir.
4 or 3.
I did 4 over 3, but I round it off to 1.
Clap easy. If I clap easy in the Sash, don't play with me. Don't play with the
Round it
teacher.
off. All right, 4 over 3.
No, 4 over 3. Yeah, man. 4 over 3. Very good, guys. And that's what it looks like. Excellent. I heard it, Jermaine. You were first out today. The stable. Very good. Very, very good. 4 over 3. Sir did all of them something with you already, you know. All right. Next one. What we got for the answer for the third one?
You get 1.
Sir.
You get 1, sir. Not sure.
You get 1, but you're not sure?
1 over 1, but me put 1.
Same difference. 1.
Okay.
Very good.
Okay. Okay.
Excellent. No, me to get up and never finish the last one, and I have 4 minutes. I can do it. I can do it. So we got 1. All right. So those of you who don't reach where we reach, it means that you're working rather slowly, and we need to improve on our speed. These are things that I have done in class long time. So this one says find the limit as that tends to infinity. Oh, no, really challenge me. Copy. Forgive me, I am working smart and not hard. So open, bam, paste. And I want what do I want? Tends to infinity of 5x plus 2. 5x plus 2. Of x minus 1, and then copy, and then I'm going to paste it right here, and each of these terms will be divided by x, because x is really the highest one that we're talking about here. So each of those terms is going to be divided by x, and then we get that, and then I'm going to copy that, I'm going to paste it right here, and then I'm going to get this piece here to just be, what do you get for your answer?
5.
Very good. So that's x tends to infinity, 1 over x, and 2 over x. Sorry, couldn't find. We'll go to 0. So copy right there. So paste it right there. So then we're going to get 5 plus 0 over that plus 0, which is equals to 5. Guys, these are easy stuff, you know, we've done this many moons ago. So everybody agrees with that? The throat clears. All right. It says find the limit. Go ahead, go ahead. So what?
I know it doesn't cut me, no, sir.
Say it
But
again?
what's the difference with 5/1 and 4/3?
5/1, any number divided by 1 is a number itself. 4/3 is actually 1 1/3. So once the number is divided by 5, I can just write the number in the numerator. Once you have a 1 in the denominator, so any whole number can be written as a rational number. So once you have 5 is a whole number, but 4/3 is not a whole number. 4/3 is classified as an improper fraction or a mixed number.
Comprende, señor.
See. All right. 7 o'clock. This one says, oopsie daisy, don't have enough time for this one, but it says no, we need to find the function. I just going to start it for you. Copy as the limit tends. Oh, come on. As the limit tends to 1. It says we need to find a function. If only I can find where am I. As the limit tends to 1. So what it is that we're doing, I'm just starting it and then we can finish it off. As the limit tends to 1. So this one here is going to be, instead of infinity, it's going to be 1. And then of course, you're going to have the Oi, that one is easy.
Undefined, sir.
Undefined to blow. Undefined. Blow is a good word here. Undefined. Boy, jeez, so we don't do question them. We say Brit. So.
Sir, you made them for their past paper.
It again?
You made them up for their past paper.
I found them in a textbook.
Oh, okay.
7 open 0. I found them in a textbook. It's a calculus. It's a calculus. Yes, it's just a calculus. Abbott and Neil calculus textbook. UNDEFINED, undefined. Oh, come on, voila. And that's what it is, undefined, and we are good to go. All right, now here what is going to happen. I'm going to send you this document. I'm going to send you the answers to the stuff. We were able to do this, go through this thing in 10 minutes. Now, those of you who are struggling, I'm going to send this off. Please to go through it. All right.
You never substitute the 1 for the 5x.
I never write it, but I can substitute it. 5 times 1 is 5.
I understand why 5 separate us out.
Yeah, sure. I want to the teacher. 5 1 is 5 plus 2 is 7, and 1 minus 1 so it's undefined. All right, I'm going to send it off. Run off to your other class. I will send this off in a few, so you can have it to review. Come next week, rubbishness. Come Thursday, we're moving. Done with this now. Moving. Yes, one.
Sorry, can you please check your message?
I will do that. Thank you.
We have business to take care of Thursday.
Sure.
Sir,
no
question. When the things on Edicosoft expire?
Log on and check for me, please. I reopen those.
Okay.
Sir, you can come about 7:50, you know, sir.
I hear you. Don't tell me that's the time your teacher normally ends a 2-hour class, you know, because that is a big something.
I know that. I don't know what happened. I don't really know anything, sir. I don't know anything.
All right. Bless your heart.
Sir,
have a good one. Take care. Bless up here. Big up on yourself.
Night, sir.
Night out.
All right, sir.
And easy.
Yeah, night, sir.
Bless your heart, Papa.
Come on, sir.
Yeah, all good.